Hello students, welcome to Sri Chendra's Rank Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 8 of units and measurement. So let's begin with this class. Today we are going to discuss about the measurement of the length. As actually if you have been go through the NCRT textbooks or some other reference books, you might have seen that this topic belongs to a very beginning of a unit, but this is important as compared to the school board classes only. Very few questions or almost no questions has been asked from this segment in the previous year competitive examinations. But I thought let's just look at this, so if there are any questions you will be able to attempt it. So let's begin with the measurement. This is actually the segment of a measurement and important as compared to the school board purpose, not according to the competitive examinations, even though we are going to cover this. So let's look at this. This is measurement of the length. Now tell me uh, which are the methods with which you are familiar to measure the length. First is the direct. We are familiar with the some direct methods. Now what is the direct method? First we are having a meter scale. Meter scale, what is it? Tell me. Yes, yes, absolutely right. A scale, something look like this. Yes. Now can you guess it? Yes. Here let's say centimeters are there. These are the mark of the centimeters. On an opposite side there are certain inches. On a standard note 30 centimeter would be marked, and if I remember about the inches, they are the approximately 12.5 inches has been marked. Between this centimeter a certain smaller segment has been always marked. They are the mm. It's a millimeter, should be written in small mm, and I know that 1 mm is equals to 1/10 of a centimeter. That all I know. Okay, so meter scale is used for length from range. This is 10 to the power minus 3 meter to 10 to the power 2 meter. Okay, if we want to measure a certain smaller data as compared to the meter scale, we have a two option. One option is the vernier calipers, which is used to measure the length to an accuracy of 10 to the power minus 4 meter. And we have one more option, that is of screw gauge or a spherometer, that can use to measure a length as small as 10 to the power minus 5 meter. So generally these are the direct methods. We can use the scale that we call as a meter scale. We can use the vernier calipers that you might have seen in the school laboratories, or you are about to see it when and when your laboratories will be started. So screw gauge is there, vernier calipers is there, and meter scale is there. Now other options, if you want to measure a large distance. While I say large distance, I mean a very large distance. Let's say they are the distances of a planet or a star from the earth. Now you might be aware that when and when you need to calculate this much larger distance, you are not going to use the meter scale. Yes, because these are very far away. When you measure a certain planet from a sun, or let's say you are going to measure a distance between two planets, these all are the astronomical distances, and that cannot be used by a simply meter scale. So what you are supposed to do, or what we are supposed to do, is we are going to introduce one more method that we call as an parallax method. Again, this is an approximate method. These are not the exact method. These are the approximate method. But by proper calculation, we have a sufficient considerable amount of data could be available. So that's why we consider this as a valid one. But this is approximate method. This cannot be an exact method. Now how this works, let's look. We call this as a parallax, and let's say we have a distance between 2 points. That means I will take an observation from here and I will take an observation from here. The distance between 2 points, this is A and B, that we call as a basis. This is called the basis. This is distance D, that is a far away from a planet P, and this planet is measured by observing it from two ends of a different. They are the A and B. We can say they are the two different places on the Earth, and that 2 points from which or from where I will take an observations. They are the separation between they are the separation between these 2 points. We just call it as an B. So what the situation is, I want to observe the planet S. Rather, I need to find out the distance of planet S from the, let's say, Earth. So what I am supposed to do is I will just look this planet from these 2 points. This is A, this is B, and this is the location where planet is situated. So what I could feel is I can have a one line over here, and I can have a one line over here. You might know that light always travels in a straight line, so that would be the straight lines. Okay, now what next? You know that in plane angle it is a theta is equals to arc divided by radius. Yes, theta is equals to arc by radius. Now what is arc and what is radius? In our case, we know that AB is the arc, and radius, it is, you can write as an AS or BS. These two are approximately equal. So what is our requirement? I need to find out the distance of that planet from the Earth, which is AS or BS. So if I am knowing the data of theta, if I know the data of AB, if I know this, I can calculate this. Yes, very easily. Okay. Next is the estimation of very small distances. If you need to calculate a very small distances, very small distances, you can use certain kind of microscopes. One of the option is the tunneling microscope. Other options are the, you can have an electron microscope, and so on. So this is the different segment. Previous one was the previous one was when you need to calculate a very large distances. Now this is the segment where you need to calculate a very bigger amount of distances or very smaller amount of distances. Sorry. So for that you can use different categories of microscope. Every microscope have their own working, and so their resolving capabilities. What I mean is their capability to measure a smaller distances would be a different. So you can use a different kind of microscopes. Next, let's look at the range of the lens. What could be the covered? So we can have various objects. We can have a various object. If I considered about the universe, then the smallest distance is approximately 10 to the power minus 14 meter, while the farthest object, that would be of 10 to the power 26. So if you consider the distance between these two, or if you consider the difference between these two, it would be a 10 to the power 26 divided by 10 to the power minus of 14. This comes to an 26 plus 14. This is 10 to the power 40. Could you understand this? Yes, that when we come to the different ranges of universe according to the length, then size of the object vary from, this is the smallest 10 to the power minus 14, and may be the this may be the biggest one. They are the 10 to the power 26. So if I take a ratio of this two, this comes to a very big number. It is a 10 to the power 40. So this is the range of the length. Now we have a certain units, we have a certain different units for different systems. You need to remember this. I repeat, you need to remember this units, as this will be very helpful to calculate a certain data. So let's look at this. One for me, it is a 10 to the power minus 15 meter. One Armstrong, it's a 10 to the power minus 10 meter. One astronomical unit, what is it? It is the average distance of the sun from the earth. This is the astronomical unit, and it is represented as a into u. It's a au, 1 au. What is it now? 1 au would be is equals to 1.496 into 10 to the power 11. Please do remember this. One astronomical unit is equals to 1.496 into 10 to the power 11 meter. Next is the 1 light year. Next is the 1 light year. It's a distance that light travels with a velocity of 3 into 10 to the power 8 meter per second in 1 year. What we are doing is, we know that speed is equals to distance by time. Now we know the speed of the light. It's a 3 into 10 to the power 8. That equals to distance divided by time. Now what is the time? It is 1 year. So there is 365 days multiplied by 24 hours multiplied by 60 minutes multiplied by 60 seconds. Now whatever the data comes, that we call as in 1 light year, and that data is 9.46 into 10 to the power 15 meter. Yes. And last, it is the 1 parsec. It is 3.08 into 10 to the power 16. It is the distance at which average radius of the earth's orbit subtends in an angle of 1 arc second. 1 arc second. It is something like this. This is 1 second. This is 1 second. So if I divide a circle, in 3600 segments, I will get this kind of arc. Again, this is a hypothetical, and this is a zoom in version of an 1 second arc. Yes, because it is seeing very bigger than this, but this is what the situation is. So you need to remember all this. You must know Fermi, you must know the Armstrong, you must know the astronomical unit, light year, parsec, and all this, as well as in addition of this, you must know millimeter. Do you know this? Yes, it's a 10 to the power minus 3 meter. Very good. Next, 1 1 micrometer. This is a symbol of mu, micro. It is a 10 to the power minus 6 meter. Next, nanometer. It is a 10 to the power minus 9 meter. Next, tell me what next to the nanometer? Um, tell me. Do you remember? Okay. So this is up to a nanometer scale. Now, which are the bigger units? Yes, it's a kilo, that is 10 to the power 3. Next is the mega, it is 10 to the power 6. Next is the giga, a 10 to the power 9. Next is the tera, and so on. So you must know this, and you must be remember about this. So this is all about the measurement of length. Now let's move to the next, which is a measurement of mass. Which are the units, or which are the standard methods that you know to measure the mass? Which are the standard methods? Tell me. One is the weighing machine that we are having. Is the weighing machine. Next, what you can remember is spring balance. Have you seen it? Have you seen this? Something like this. And here we just hanged up uh, an object that I want to measure the mass. Okay, one is the weighing machine, another is the spring balance. One more option could be the beam balance. And more option could be the beam balance. That is the something like this. Uh, let's say we put an object of which we want to measure the mass, and here we will place as standard units, and generally this is to be kept in a glass plate. So this is beam balance. Generally in previous days we are using this to measure the mass of ornaments, to measure the mass of an ornaments and so on. So this is all about the measurement of masses. We have a different approach, we have a different methodology, and we just calculate this. Next is the measurement of time. How we measure the time? Tell me. Direct method, indirect method. Tell me which are the measurement of time. Yes. First, which is it? First. Yes, it's a watch. Next, next, next. According to the sunrise and sunset, even people in village, even on these days, even not, even at 2020, they used to calculate the timing. Again, that is an approximately timing, but they can get it that if sun rises it is approximately 7 in morning, or if sun sets it is approximately 6:30 in the evening, and so on. Next is the sun clock. You might have seen this sundial, what we call as an, it's a sun clock. Next, have you seen this sand clock? Have you seen this? Certain this kind of construction is there, and let's say a sand is available in this and it is being poured into the other arm, so it's a sand clock. So this all are the approaches, or this all are the methods to measure the time. Yes, you just go through once, because this is not important as compared to the competitive examinations. This is not important, this is important as compared when we refer or when we want to go for the school and board examinations. Yes, so just go through once. Okay, so is it clear up till now? So now let's look at the very important topic of our unit. It's in previous year asked questions. We will always go with this. When and when once a unit would be a covered, once a unit would be a covered, we will be having a last lecture. We will be having a last lecture that is of previous year asked questions. Yes, so do remember these things. Now let's look at the questions. When and when we are going to discuss the previous year asked question, you would be having a pen and paper with you. You must calculate this, and next, and then we are going to matching the answers. So go through this question. What is the data? What all they have given? They have been asked that the pressure on a circular plate is measured by measuring the force on the plate and radius of the plate. If the error, if the error in the measurement of the force and the radius are 5% and 3%. So what they have given, if the error in the measurement of force, that means they have given that delta F by F, it is a 5%, and radius, that is the delta, let's say write it as an R, it is a 3%. Okay, which kind of plate is it? It is a circular plate. Okay, the percentage error in the measurement of pressure. So how can you solve this? Can I write like this? It's a pressure is equals to force by area, and for area I should write it as an force by pi r square. So if I write delta P by P, it should be delta F by F plus twice of delta R by R. Yes, yes. Okay, now let's put it up the values. Delta F by F, that is a given as a 5%, plus 2 into delta R by R, it is a 3%. So this is 5 plus 6, and that arrives as an 11%. This should be the answer. What was yours? Can you do this? Okay, very good. Now let's move to the next question. Go through question very carefully. What is given? They ask that the physical quantity which has dimensional formula is same as this. Now first I need to calculate the dimensional formula of this. it's an energy, which is, if I make a unit of energy, it is kg meter square per second square. Mass, that means kg. Length multiplied by meter. Yes. So this kg gone, this meter gone. So that comes to an meter per second square, which is same as the acceleration. This is the correct answer. Okay. Always consider one thing, when I need to solve this kind of questions in competitive examinations. While I mean a competitive examinations, I mean that I needed only the answer and not the methodology that how this answer has arrived. What I need to do is I need to just write a unit of this. Do not go up to the dimensional formula. Let's say if I write a dimensional formula of energy, it is m1 l2 t minus 2 divide by its in mass. So I will write an m1, its ln, then l1, and then I need to solve this. So this takes a very higher amount of time. So let's say this is m1 minus 1 and l2 minus of 1, and this is t minus 2, and then I need to solve this. No, 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 do not do this. You just write it down their units. Yes, and then solve this. This will speed up your calculations. This will save a time for you, and that time can be utilized in a bigger numericals. Okay, so let's look at the next question. The energy density and pressure, this two must be having, what is it? So let's find it out, the dimensions of the energy density. Energy density, do you remember the formula of energy density? Do you remember the formula of energy density? When word density arrives, that means it is divided by volume. So it's an energy divided by volume. Now energy, it's an kg meter square per second square. Volume, it is meter cube. This is meter square, this is meter cube. So this is kg per meter into second square. So this is energy density. And next is the pressure. Pressure is equals to force by area. Now what is force? It's a kg meter per second square divide by area, that is a meter square. So here meter is there, here meter square is there. So the remaining terms are the kg meter into second square. Look at the units. Both are having so units. Both are having same units. And when they are having the same units, they must be having the same dimensions. So these two are having same dimensions. What was your answer? Can you match this? Okay, great. Let's move on. Now dimensions of 1 by mu naught into epsilon naught, where symbols have their usual meanings. Now look at this. If you have gone through your study material, then in previous year asked questions, you find so many symbols that you don't know at this stage of time. So what the situation is, when any examinations has asked certain things, let's say JEE has asked some certain questions or NEET has asked certain questions. So that examinations were attempted by a student who have gone through the 11th class complete syllabus and 12th class complete syllabus. Now at this point of time, you are at a stage where you don't know many of the quantities such as this. So what at this point of time, I have taken only those questions, which for which quantities is or quantities should be known to you. I have not taken those questions. Of which quantities, there are certain quantities that you don't know. I have not questions that uses the calculus, that means differentiation and integrations. I have not taken their quantities because you at this point of time you are not knowing a good amount of differentiation or integrations. Yes, so let's look at this questions. This is mu naught into epsilon naught. In 12th class, in the electromagnetic waves, you are having a one relation like this. C should be is equals to 1 upon under root of mu naught into epsilon naught, where c is the speed of light, speed of light c is the speed of light. So what I required 1 by mu naught epsilon naught. So I should square this on both the sides. This is mu naught by epsilon naught. This is what I require. So this is c square. It's a meter square per second square. So this is L2 t minus 2. Okay. If you don't know this, don't bother at all, because when you come to the class 12, you are going to teach a unit that is an electromagnetic waves, and you would be having a knowledge of this. So if you don't know, don't bother. Yes, let's move to the next. Dimensional formula for the torque. Dimensional formula for the torque. What is it? Tell me. It's a yes. Force multiplied by, I should say, perpendicular distance. It's a force multiplied by perpendicular distance. Now force, it's a kg meter per second square. Perpendicular distance, its unit would be a meter. So if I write like this, it's a kg meter square per second square. What would be its dimensional formula? Look at this, kg having a power of 1, so it is m1. Meter square, it is l2. Second square, this is t minus 2, so that should be m1 l2 t minus 2. This is the correct option. Yes. Yes. Okay, let's look at the next. That they have given is force F is given by the relation, which is F is equals to x divided by linear density, and what they require is they require dimensions of x. How can you do this? So what I should write is x should be is equals to force multiplied by linear density. Now what are the units of density, or rather I should say a linear density? So linear density, it is same as a density only. So density, it's in mass per volume. Yes, it's a mass per volume, and if I make a unit of this, it is kg per meter cube. Remember these things. Now let's say x is equals to force multiplied by density. Let's represent it as a rho. Force, it is the kg into meter per second square multiplied by density, it is a kg per meter cube. It's a kg per meter cube. Here it is kg, here it is kg. Meter cube. So if I cut it down, it is a meter square. So what the situation would be, they are the kg square divide by it's in meter square second square. This would be the situation. It's in kg square divided by meter square into second square. Yes, find out the option and do it. Good. Let's move to the next question. They have given us, if the force is given as F is equals to AT plus BT square, while T is the time, and they have been asked that dimensions of A and B. So which principle can you apply over here? Which principle can be applied? Yes, it's an equation of homogeneity, or rather I should say a principle of homogeneity can be applied. Do you remember these things? We are used to tell something like this, that kg should be equals to kg plus kg. Yes, only those quantities can be added or subtracted which are having same dimensions. So here force has been equated with the A into T, while A is the constant and T is the time. So I can write like this, F should be is equals to AT. So if I want to make a dimensions of A, it should be an f by t. Now what are the units of f? It's a kg into meter per second square. For time it is a second always, so this is kg into meter divide by second cube. So this is kg into meter divide by second cube. And what about the b? So what I can write is f is equals to bt square. F is equals to bt square. So b should be is equals to f divided by t square. Now force, it's again kg meter per second square, again 1 by t square, this is second square, so that comes to a kg into meter divided by second to the power 4. So if I make dimensions of this is m1 l1 t minus 4, and if I write this, that's an m1 l1 t minus 3. Second option. Yes, can you do this? Which is your answer? It is the same. Very good. Let's find it out. The next question, go through it very carefully. They have given that resistance of a given wire is measured by measuring the current flowing through it and the voltage difference applied across it. What they have given is key percentage error in the measurement of the current. Yes, it is okay. So percentage error in the measurement of current and measurement of the voltage, both are the 3%. Then the error in the value of the resistance of the wire. Now do you remember any relations which relate to voltage, current and resistance? Can you? Yes, in previous years you have been gone through this. V is equals to IR. So if I write like an error, because the errors are 3% only, so that can be calculated as an error. Delta V by V should be is equals to delta I by I plus delta R by R. So I need to find out this. So if I write like this, delta R by R, then I should write as delta V by V plus delta I by I. Yes, okay. Now you might thinking that, sir, if this came on this side, it should be a negative. But remember the words, errors would be always added. Errors would be always the added. So I need to take a maximum possible component of an error, and maximum possible can be calculated while I am going to add this to. So remember these things, error would be always added. Now let's put up the values. So they are the delta V by V plus delta I by I. It is a 3% plus 3%. So this comes to an 6%. This is delta R by R. This is delta R by R. Got it? Yes? Okay. Let's move to the next question very quickly. What they have given is pressure. What they have given is that pressure depends on this much things, where alpha and beta is constant, z is the distance, and k is the Boltzmann constant, and theta is the temperature. They want the dimensions of beta. Now calculate by yourself. Do it. You have a 1 minute of time. Can you do it? Just try it and go through this. Can you do this? Can you? Okay, great. So let's look how we can do it. We know that power of the exponential, all are the dimensionless. Always all these things would be a dimensionless. So this is its power, exponential. So what I can write is alpha into z divided by k theta should be equals to 1. So if I can write like this, I can always write like this, that alpha into z should be equals to k theta. And when I know this, I can write like this, alpha should be is equals to k multiplied by theta divided by z. It's k into theta divided by z. Yes, let's, this is relation number 1. And one more thing, while this is dimensionless, I can write like this: P should be is equals to alpha by beta, while P is the pressure. So if I know this, I can write like this: beta is equals to alpha by P. What is alpha? It's a k multiplied by theta divided by z multiplied by P. Now all the dimensions, you know the all the dimensions. Probably there is a problem with the Boltzmann constant. How can I find it out, the dimensions of the Boltzmann constants? I know this: PV equals to N into KB into T. Here KB is the Boltzmann constant. Here KB is the Boltzmann constant. So you can write like this: KB is, it is equals to P into V divided by temperature, while N is the number, so it is a dimensionless number. Temperature can be represented as theta multiplied by theta divided by z multiplied by pressure. So this two would gone, and you might do rest of the things. Yes, yes. Any error? Anything? So let's say this is temperature. This is volume. Volume represents the meter cube. Z is the distance. They have given in data. Z is the distance. So this is m. So meter cube per meter, it's an meter square. And this would be the answer. Yes. Were you be able to solve this? Were you? Are you sure? Okay. Very good. Now, next question. Go through this very carefully. You have 2 minutes of time to solve this. Just do it. Can you solve this? Can you? Can you solve this? Okay, let's look at this. What they have given is the period of oscillation of a simple pendulum can be calculated by this. Measure value of L is 20.0 and is none to 1 mm accuracy. So what they have given is delta L. A probable error in the measurement of the length is 1 mm. If I convert this to a centimeter, it is a 0.1 centimeter. And the measured value of L, which is the true value, or rather what we can say is 20 centimeter. This is centimeter. Next, and time for 100 oscillations of the pendulum is found to be 90 seconds. So true value of time, it is a 90 seconds, and that is calculated using a wrist watch of 1 second resolution. What does it mean? That says it is a delta t. Probably the error, probable error would be the 1 second. The accuracy in the determination of G, what it would be? So what I can write like this, that t square should be is equals to 4 pi square multiplied by L by G. If I write all this according to the error, then I can write like this: twice of delta t by t should be is equals to delta L by L plus delta G by G. This is the data 4 pi square. This is the 4 pi square. So if I consider this 4 pi square, this is a constant number, and when this is a constant, we do not need to put any dimensional formula for this. So I need to find out the G. So I should like that this delta G by G should be is equals to twice of delta T by T plus delta L by L. Again the same thing. Errors are always added, so it would be on positive. So this is equals to 2 multiplied by delta T. It is delta T, it is a 1 second, divided by total time, it is a 90, plus plus delta L, it is a zero point 0.1 divided by 20. Yes, can you do this? Now, can you do this? Are you sure? Are you sure? What it would be? What it would be? Tell me what it would be. Calculate it on your own. Calculate it. Can you do this? Can you do this? Okay. I'll leave it up to you that you need to calculate the delta G by G. Are you sure? Okay. So let's wind it up here. What we have gone through is we have done those kind of questions for which units you might know, because when you go through the previous year questions of this units and dimensions, there are so many quantities that for that units you might not knowing. Why you don't know about that units? Because those are the part of the upcoming syllabus of 11th unit as well as 12th. So what you need to do is you need to just go through the table having the units, having the different physical quantities, their units and their dimensions, and you need to just try to solve this. Okay, so you need to practice a lot for the dimensions, for the errors questions, and for the certain questions of measurement too. If you do it, you will be go through this for the units and measurement, you will through with this unit. Okay, let's wind it up. Thank you. Bye bye. Have a good day. Take care.